Good day, class. There's a little bit more about dosage we wanted to cover, so I just labeled this one dosage 2, and it has a lot to do with parenteral administration of medication. So much of what we see here will be medications that would generally be administered in places other than through the digestive tract. So you all may know more about that than I do, but at any rate, let's move right along. So in this first example, the doctor writes an order for 13.5 milligrams of ephedrine sulfate subcutaneously. And the vial is labeled for 45.5 milligrams per milliliter. So this is not at all difficult for you. You can just fly through this part because you'll recognize immediately that there's a relationship between milligrams and milliliters, and then you'll substitute your values. Obviously, you'll cross multiply. I just wanted to kind of stick this in there and remind you that when you cross multiply those unit measures, the milliliters and such, they will cancel as needed. Forgive me, the milligrams in this case will cancel as needed. So I just want you to be respectful of that because we do skip that step often. But just realizing that they cancel in division operation. And then here, I see that 13.5 is equal to 45.5x, and of course I'll divide by my coefficient of x and uncover the previously unknown number of milliliters that contain 13.5 milligrams of this substance. And in this case, 0.297 milliliters is what we need to obtain 13.5 milligrams of this substance. And then just be respectful that in some cases you will need to round. This one I would expect maybe round to the 10th to 3/10 of a milliliter. In this example, the doctor has written an order for 23 milligrams of amitriptyline, and the vial is labeled as having 10 milligrams per milliliter. So as quickly as I would, you would recognize that there is a relationship between milligrams and milliliters. You would set up your proportion, cross-multiply, and solve, and reveal that for 23 milligrams, you would need 2.3 milliliters of this substance. But the kicker here is recognizing that 2.3 is the same as 2 3/10, as long as you're respectful of the place value, which is crucial, then you'll recognize that because that 3 is sitting in the tens place, we have in fraction form 2 3/10. So on a syringe, here is 2 1/10, 2 2/10, and here lies 2 3/10 if we're talking about the number of milliliters on this syringe. And notice how in this example, I'm looking for 75 hundredths. So I'm kind of looking for 75 on this syringe. So there's 0.70, 0.71, 0.72, 0.73, 0.74. I missed a, I hope you'll bear with me, and 0.75. In the same regard, here I am looking for 83 hundredths of a milliliter, and so you can see just 3 steps to the right above 0.8 is my 0.83 milliliters. Same idea with 0.79 milliliters. We can see we're 79 steps into our syringe of 1 milliliter. In this example, where an order for lidocaine is issued, 250 milligrams IM stat, and the vial is labeled 20% milligrams per milliliter. So we recognize that we do have a relationship between milligrams and milliliters, but we also must recognize that 20% lidocaine means that there are 20 grams in every 100 milliliter. And so with that, we can very quickly at this stage in our understanding convert grams to milligrams. And so instead of the 20%, we're going to represent this as 20,000 milligrams per 100 milliliters. Now I can use that relationship here because I'm looking for the number of milliliters contained in 250 milligrams, or that contains 250 milligrams of my medication. And so this is the relationship that I need. Now I can cross multiply, I can simplify, and discover that there are 1.25 milliliters needed to obtain 250 milligrams of my medication. And be careful again about rounding, because here's an example where you'll probably be asked to round to the nearest tenth, and recognize that we're talking about 1.3 milliliters if we round that. In this final example, we're an order for hydroxyzine. Forgive me, my vocabulary is not as good as yours. Pomoate at 60 milligrams for every 14 hours. Okay, so this is our order, and we realize that 5 milliliters will contain 10 milligrams of the medication. Then we're asked for the number of teaspoons that should be given, because this is some order where we're receiving teaspoons of a medication. And so we need to know, well, how many milliliters are in a teaspoon? So once we can get that conversion or that relationship, then we can proceed here. So I'm going to set up my relationship again from milligrams to milliliters, and then represent that there are 60 milligrams in some unknown milliliters. But I also know that for this substance, my container has 10 milligrams of the medication in every 5 milliliters. So with that, I can complete my proportion by cross multiplying, and then of course I'll divide and discover that there are 30 milliliters that I'll have in order to have my 60 milligrams. But I'm issuing this medication in teaspoons. So if I know I have 30 milliliters to administer, then how many teaspoons will give me the 30 milliliters is the question I will have to ask myself. And so I can divide that 30 milliliters by 5, because I know each 1 teaspoon is going to cover my 5 milliliters. So how many of those sets of 5 do I need is my question. And then I discover that I need 6 teaspoons administered in order to accomplish the 30 milliliters that I've also discovered.